Hello guys, welcome back to Monster Studio. This is part 2 on the course. If you haven't watched part 1, you should go back and watch part 1. Okay, so I haven't got the presentation for class, but I'll briefly explain what class is and why we use it. But in the previous tutorial, I asked for you to create an instance of an object, maybe a human, and see whether you can print the talk to the screen. So let's do that now before we get into anything else. So I'll create a new file instead. Okay, so you might have guessed that you need to add the talk method to either to the prototype or put inside the scope, but I did say it wasn't practice to put inside the scope. So give yourself if this was a test, you'd be getting a mark for using the prototype keyword, an extra mark. I'm returning maybe a text that says hello, I'm first name and last name, because you're using a prototype. Because this is best practice. Any developer seeing you using this syntax will see that your code is much more organized, and it shows you can organize yourself. Okay, this is bumming me out. Okay, okay. So how you do this is through the human prototype. So human the prototype dot get age. I mean talk. Okay, this is taking a Visual Studio Code is just refreshing. So you can type in okay, once more. Okay, this is taking a bit of a while, so be patient with me. Okay, okay, we're just gonna reopen Visual Studio Code. Give me a second. Okay. Um, I'm just reopening Visual Studio Code. Okay, let's continue. Okay. Wait for this to load up. You can skip ahead about 2 minutes. If this video gets above 30 seconds, above 30 minutes, I'm going to stop it. Okay, let's continue. Okay. I'll create a new file called basics classes. Okay, now I have these two files. Begin to create the instance. So if we can make Alexa to talk like no, please. Since why this is working is because Alexa's name is null, and because it's string concatenation, and JavaScript is basically typed so we can parse, concat variables and strings, but we don't have to. Just a quick reference: we don't have to cast them. We don't have to convert them through an interface of some sort. But we'll learn interfaces later because this includes it. But Alexa talk says Alexa, hi, my name is Alex. My name is Alexa null. So this is a string Alexa wrote because it's taking the first instance and concatenate it weakly typed, so we can add all the strings together. It's not Node.js feature, it's a common JavaScript feature. So what is a class? Let's just take this human constructor. Okay, my understanding is a class is a blueprint for an object, a blueprint for a constructor, for example, and a class constructor. So if you wanted to have a type of a human, an instance of a human that behaves in such a way that you control it, you have more. A class allows us to have more control over constructors. So if I was to say, and this is how we initiate a class in JavaScript. Okay. I'm not sure. Put a tail there, so click. Okay, so we've got our class. This is how we initialize a class. So we've got a variable named human assigned to a scope. This scope is the class initializer. It will tell us that we're gonna evaluate this whole scope to return the class instance. So when we have a human and return it, we're evaluating this scope. We're evaluating this scope to this human function, human constructor, to be this scope, and anything we type here, we can use that to structure like a map out. We map out a blueprint for this human constructor. So a class is not always an instance, but it maps out this human because it's returning a human every time. But in this scope, we can structure what the human does. So let's add a human prototype. Dot. Give me a second. Okay. So this scope is being evaluated by this curly bracket, this function curly brackets, because we're inside this scope and the return type of this human is being passed to this. So what this says is evaluate this scope or this human because it's as its return type. We can also evaluate it with having this outside the scope, this, and make this a type of human. So this human now is being evaluated. This whole scope, this human pointing to this scope here is being evaluated as a type of human. So this whole scope is being evaluated. So we can create it. Say we had multiple instances of like a human that drives a car, and we had a car in here. Maybe we have a car in here, and we wanted to also evaluate it. We can only have one return type because that's the return keyword works. But I'll show you how to get passed around that later on through the video. Okay. If we evaluate this scope, what do you think will happen? Once this scope is evaluated, the type of human.
Man.
So if I type in var, if I create a new instance of this, create a new instance of a human, it's a type of human, so it's a constructor. So anytime we can use this to structure our code a bit more. So I did say that we as Java developer, I like working on my own scope. This is what I meant. We have our own scope. We're not in the global scope, and we're not pointing to the global scope. We're not using the global scope to evaluate our code anymore. This is best practices because you have your own code to work in. This is what I mean by this is why object-oriented programming is important, because you learn to handle scopes. And this expression here, function expression, or constructor expression, is a function. It's now evaluating this whole scope. So var Amy equals new human. Amy Watson, year 2018. Oh, I don't want to change that. I want something hard for something harder to compute. Okay, 2019. Let's say Amy's really old, like she's a mummy. She's probably dead. It's current year 2019. And we want to log out Amy. You can see Amy is a type of human, and this human is saying that Amy Watson is this human is holding objects. So this is much more better. The reason why objects are better than factory, I forgot to mention in my previous video, was because constructors take 2 milliseconds. It's almost 2 milliseconds faster than a regular constructor, and it's easier to be passed around. You can pass it at any time as well because you can store it in a variable and pass it as many times as you want, and it's much more efficient in storing memory if you're creating loads of instances. But if you're creating just one instance, or you're not using a factory, if you're only creating one instance and you can use a factory function, like human factory function, to create one instance that's gonna be tossed around, but that doesn't need to be done. Yeah. So let's go over this. So this is an instance of a class. If I type in use strict. I'll just play this use strict word quickly because it's very important. It makes this this keyword, when we're working on object, this keyword here cannot point to anything. Will not be a pointing because this function is now this keyword in this scope is now undefined, because in the regular function scope this keyword is bound to the function itself. If the function has a name or variable name, or variable name, but these structures to this keyword. So now we can declare our own instances, our own types, and return them. Okay. Another way to do this. This is ES5 syntax. This is one way to do it, but we can do it. We can do it even better. But first, we have to speak about polymorphism. Let's log this out. This keyword now becomes undefined. It's not pointing to anything, so we can declare our own types and own instances, like I said. Okay. If I were to log this, we're pointing to this scope, which should be undefined because it has no name. Because the function always returns undefined, no matter the name. So, okay. Let's define an instance. Let's say we want. Let's change this to humanoid. There's something called polymorphism. So when we wanted to when we're working with different types of data. Let me spell that correctly for all you judgy people out there, but I don't have to do that. So I'm just trying to make this as perfect as possible. So when we want to make a humanoid now, we call this the first name, last name. But let's say we wanted to also inherit the properties from this humanoid. Well, there's a way to do that in just a second, but first of all, we're going to create another scope. So this class is being evaluated as a humanoid. And this humanoid has talk and get age. So let's say we had an alien. And it's a type of human. We can redefine this whole scope to create a new human, but this class is now evaluating this humanoid, the same thing, but we have a better way of doing it. There's a much more better way, efficient way of doing it, because object orientation is just about optimization and getting it down to writing less code, because this class is being evaluated through and it's a type of humanoid. But so let's say we wanted this to be a type of alien. So what I just did now is said that if you look at this class, I think you should take some time to get this down and understand what I'm saying. What I'm gonna say now, this is a class, and here's a prototype method, alien or prototype, and the return type is of alien. but we want this to also extend a humanoid because that's what an alien is, a humanoid. So we don't have to. So we can write the humanoid function in here and evaluate it. But that's not really practical. That's not in good practice. That's not a conventional mean of programming, and it's not very practical in the real world. You in a test you may lose marks, but it's best you copy this. So to create an instance of humanoid, we can have to bound the prototype to the new. This prototype keyword is always important, will be important in any aspect of programming because it's where all your prototype, the prototype keyword, prototype property on the constructor is a way of saying that all instances of that constructor has that method or function or type. So we're gonna specify a new type. So var alien equals new humanoid. Oh, sorry. That's incorrect. Object dot create. So every time object dot create human. Oh, sorry. One more time. I'm not thinking today. Oh. Okay, so this prototype method is binding to new humanoid. So every time a prototype is called, it will have all these prototype methods of the humanoid from the alien property. So it will take the first name, last name from this scope, class scope, and append it to this prototype property of the alien. So let's say Ania equals new alien. Ania Katerina. Oh, sorry, Katerina. She was born in the mid 1998. Very old. Maybe she's a millennial. I don't know. Not yet. And the current year is 2019. If we're to log Amina out, we should see she's a type of alien. But if we're to call the get age on her, we should see that it works. Oh, human is not defined. In this scope, human is not defined. Okay. Okay. Now you see that it works. Get age, it works, and it's now inheriting. There's even a better way to do this, because that's the thing with object-oriented programming. You have to it's just a key concept of handling data and when processing, and this is why we have a secret file project detection skill, and I'll deal with you. So Amina, the get age, is inheriting from that the prototype of the humanoid, because that's what she is. She's an alien. So this class, we can define the class another way, an even easier way, so we don't have to write all this code. Remember the syntax. It's this method. This is what we'll call polymorphism with the new, because this alien is being inherited from this humanoid, the prototype, and now it's getting an age. This is what polymorphism is all about. So you don't have to create multiple instances of classes to handle run the same processes on a type that's kind of similar but isn't as similar, because an alien is a type of humanoid and a human is a type of humanoid, but it's best to have a one generalization of a class and an interface of a class. A better way to write classes with the class keyword, and I'll show you how to add polymorphism and inheritance. So let's create a new file. Okay. Okay, this is taking its time. So Amino is an alien and is of A21. This is one way of handling objects. She's a constructor. So a better way to create it is with the class keyword. I'll show you how to use that, because a class is an instance of a constructor as well. So it can have an instance of a constructor. Okay, this is taking a while. Okay, new file, and click. Okay, skip 10 minutes and okay. So I was gonna say we're gonna use the class keyword to create an instance of human or of class. I'll show you how to also add polymorphism with ES6 classes. So we're gonna create a new file called classes oop.js. Okay, with a class you can make an instance, but with classes we don't have we still have control over our objects. We still have control over our objects, but sometimes it's having a literal class initializer. Literal class initializer is better. It's much more better than having a oh, let me close this quickly. Don't want you guys to see that. Having a literal class initializer can benefit you in the long run, but if you define with a class keyword, there's no you don't have any errors. But I'll show you why these two are one of why we can use them, both of them. You can still use both of them, but I prefer to use my the class control. But when I'm working with very big files, then I prefer to use the class. It doesn't matter which one you use. I'm just being honest. It doesn't matter. Okay. So how we initialize is with the class keyword. So we type in class, and then the class name, human, constructor, first name, oh, let me just copy this. I'm not gonna waste any of your time. Okay. Okay. I'm going to do something with Node.js because we can also have imports in Node.js. I'll show you how to do that, but this is not Node.js code, so I'm going to show you what to do this one thing. So we're going to export this humanoid and import into class up so we can use it, but you can use it as well. So I'm going to export module. So that's printed this module. So exports equals export. That's just telling pointing to this object export robot. So this exports is bound to this module exports, and we're just making sure, we're just assigning it to make it really sure equals humanoid. So now when we require it, when we together we say we make a variable called humanoid equal to require, this is a common JS syntax, dot slash basics oop classes. I think it's dot, oh yeah. So this humanoid is, this module is taking this humanoid out of this and putting it, we're using it in this file. So this, when Node.js says shared state, so every file, this file being required is sharing states now, it's sharing the same variables and over exports, same processes. Okay, so we created a class called human. So to add the reason why to add polymorphism to our class, we use the extend keyword using extend humanoid. Now we don't need to add all these properties to our class human. We don't have to add all these properties to class human because it's now inheriting from what every humanoid should be able to do. That's an instance for a class. It maps out it's a map out for another class, or we can use it to structure another class. So we can now log new human Zenny, oh Lenny, Zenny, Carlson, 2019, 1998, oh I don't know why, 1992, currently it's 2019, and we can now call the talk, it extends this human. That's way of adding polymorphism. We can also use this other ways, but this is the preferable ways. This is the preferable ways. You can Google an MDN on the MDN website using the call method that we've been talking about in the previous tutorial. I think part 1. Yeah, in part 1 to call, but to call it indirectly. Okay. But this is preferable ways of doing it. So if we take this out of the scope, Lenny, ooh, okay, that's new. So if Lenny talks, Okay, this is the first name is not. Oh, so the super keyword, it says must call super and derive class before you can actually discard from the derived constructor. Super keyword is just a pointer to the humanoid. So every time we call super, it's saying okay. I think. Okay. Okay, super is just pointing to the humanoid. So we need a super keyword to super function to point from the constructor to the extended human. So now we can assign these, and we can get my name is Leonard Carlson, and that's his name. And that's I'm thinking of instances now, but I'll ignore that. Anyway, we think the same. It's a bit actual, so let's not think about that. And that's learns a human. It's a certain type of human. This class is much more simpler. It's much more easy to understand. It's much more. And we can create more classes. This class and this human can even class. It's much more easier, and we write less code. But we use this to organize functions. In Python, for example, we use classes to organize the units of functions. In JavaScript, we use Python to organize the unit of construction of functions. We can have static methods. Static static has job okay, get job equals a function this we have to call the super. I think we have to call the super. No, we don't have to call the super. We can use constructor. We can use the this in the class. This dot first name plus this dot last name guts plus guts job so anytime if we log Lenny.get job, you can see it returns a string. Let's call that. Oh, is that a keyword? Oh. I forgot the syntax. Oh. I think I forgot the syntax. Well, before we make this reference, I'll show you how to use it in ES5 classes instead of ES6. So we're just coming this out, and let's say an alien. Let's say an alien gets a job. So to add a static method, we say an alien dot get job equals to a function. So anytime we call an instance of get job on alien, it's on an alien object, we can then we will get this return. This is what's called static, or this is static type of variable, and this can be in here as the return type. This is private to the alien itself. This is also the same as returning an object in here, but this is not best practice. It's best to return this keyword, so you always return to this pointer, whatever is pointing to it. So for example, if I'm returning an object in here, and an object in the constructor, I can make this private. This is the same as alien.getJob is always equivalent to a return type of alien. But this is much more best practice, because if you keep working on this scope and have a return type, you're gonna have a control flow problem. You don't know what code is bound to which, and you're not organized at all. So you'll be marked down. Your code will be very inefficient, very slow. You'll be even marked down. Okay, so this having a return type. This is a private instance. This is a private method as a function, because it's bound to get this. So it's only an alien that can call this getJob. So if I said, so this alien is a type of human, okay, this alien is a type of humanoid, and this humanoid does not have a getJob property. If I try to create a humanoid to get a job, because this is bound to alien only, because this is bound to alien only an alien can get a job, not a humanoid, because not a humanoid. And this alien has a property of humanoid, not the other way around, because this humanoid does not inherit this alien through the new keyword, and therefore only an alien can get a job. So if we log amino.getJob, we should see that amino.getJob. Oh. Okay, what happened? Give me a second. It says amino.getJob is not a function. Oh, that means we can only use it in this code as well. I forgot. You can't call it directly, because this alien, we can only call it in this class because it's private. It belongs to this. It's private here. It's private here and here. This controller is not returning this get age immediately. But I forgot one thing. I forgot one very crucial thing. This alien getJob can be called outside the scope because it's bound to this alien constructor and not the prototype object. So as it's not bound to the prototype object, this alien is returning the prototype object, and the prototype object is pointing to this. If I was doing this in here, the prototype object will be pointing to this keyword. We refer to this keyword through the alien constructor itself. But here there's no alien constructor, there's no prototype method, so you just attach to it. So I have to for every instances. For every instance of alien, you can log alien okay. Am I wrong? Yeah, it worked. So this private variables are already do is to structure a class in such a way that it's using its properties, but this object has properties with private to it only, and we can do that with classes as well. You can Google this. Doesn't get job. Oh yes. This static method is not. It's saying that we're only having it's static and it's pointing to this construct still, but it's getting the job, and there's a little bit of a difference. We can run this outside the scope. Let's try that. If we can't, then I think I have to read up. Okay. So we can't use it outside the scope. We can use it inside the scope because it's private. It's private to the humanoid. That's the same thing as doing it that way. Okay. Okay. So now, but we want this to be bound to every humanoid, or like every human, every class that extends humanoid. So every time we call humanoid, we have to pass it through the prototype property, and then print out from there, structure this class to print out for all human properties the prototype of that. So we can take this code here and put it here. Okay, so now every instance of humanoid, it must be a type of humanoid, or it extends it or implements it in some way, can now access get job. That's why object-oriented is like very important to learn, because you need to learn to parse variables and instances and a lot. In the next tutorial, it's gone past 49 minutes now, so I'll stop the tutorial and we'll continue on the next tutorial. So thanks for watching and stay fresh. Next tutorial, but first I would like you, before leaving, I would like you to try something. Create a class try creating a class named what's this? No, that wasn't gonna say. No animals, and try extending from an animal class to the type of animals you would like to see in the object. From an object, and giving them properties like whether it has 4 legs or 8 legs, something simple, to give you good practice, give you good practice on handling objects in object construction and classing in JavaScript. You can either use the class, try one with the class and one with the opening scope. What's it called? Brackets. One with the opening brackets, and see what you can do with it. Do not use the object literals, but return and also have a type of human. Okay, thanks for watching, and again, stay fresh.